In this video lecture, we're going to discuss postulate and theorem. So it is used for Boolean algebra simplification. So let's start with postulates. Postulate 1 defines what is Boolean equation. So definition, Boolean algebra is a closed algebraic system containing a set of K of two or more elements and the two operators and or. So basically, Boolean algebra contains variables and with operations or operators like and or. So let's move on with postulate 2, existence of 1 and 0 element. What is the effect of 1 and 0 in our equation? If we're going to OR a variable to 0, the result is the original variable. There's no effect when we OR a variable to 0. Still A. And in case if we want to add any variable to 1, it will be the same variable. The value is still the same, A. There's no effect if we're going to add 1 to a certain variable, still that variable. Okay? Postulate 3, commutativity. The order of variable doesn't mean anything. We could change A plus B to B plus A. They have the same meaning. Even AB still the same as BA. Okay? So now let's move on with postulate 4, associativity, association of variables. Okay? So A plus B plus C, as you can see here, B is associated to C. As long as the operators or the operation is from 2 are the same, we could change or alter the association. Since A is associated to this term through OR, and B is associated to C, therefore we could change the association of B from C to A. So they have the same meaning. Same as with, we could associate C with A, since from 2 is the same OR operators. Okay? Another form of postulate 4. A and to B and C is equal to A and B added to C. So, as default here, B is associated with C. Since this term is associated with a true end, therefore we could change the association of B from C to A. Okay? It will not change the meaning of the equation. Same as with, we could associate C with A. It will not change the meaning. Okay? As long as from to is the same, we could use postulate number 4. But in case we're going to associate from and going to or, we could not implement postulate number 4. Don't forget that. Okay? Postulate 5, distributivity. This is one of the postulate that we're going to use every now and then in simplification, in proving that given equations are equal. Okay, so distributivity is like factoring or distributing or like multiplying variables to our terms. Okay, so first form, A or to BC is equal to A or B added to A or C. So we could use the first form in case we want to get a factor form of A or BC. So we could separate the term ANDed under AND operation. Okay, so BC, separate it in a different term, and then the other term will be common between the terms. So that's how form A works. BC, we have two variables, it means two terms. And separate BC, B for the first term, C for the second term, and common A, and then each variable will be or inside the term. Okay, and form B, A added to B or C is basically AB or to AC. So simple distribution or simple multiplication of variable. So AB, A, distribute to B and C. This is the result. Okay. Postulate 6. Existence of complement. What is the effect of complementing each other? Okay. So if A or to its complement, the result is 1. Second form, if A is added to its complement is equivalent to 0. Why? Because in this equation, we're going to have always an input of 0. Okay? If 1 is A, therefore A naught is 0. 1 added to 0 is 0. If A is 0, even though it will become 1, if we're going to not negate it, okay, so still the result is 1. Same as with the form A, there is always an input of 1. If A is 1, automatically the result is 1. If A is 0, but if we're going to complement it, it will give us an output of 1. So 0 or 1 is still 1. Okay, so that's postulate number 6. So don't forget the different postulates. We're going to use it for simplification and proving equations. Okay, on the next video lecture, the different theorems that we're going to implement for simplification of our equation. Thank you for listening and see you on the next video lecture.